This video is going to be on my attempt to straighten out this Criterion boring head. The boring head itself is in good shape. It is, however, very bent and unusable at this point. It's an American-made boring head, and I'm assuming somebody crashed it into some work that was, I don't know, they just had a bad day. So I'm going to turn this on at 70 RPMs. It's in low range. Show you the runout currently. Now, I'm measuring this runout right at the base of it. The actual shank itself is straight, so the damage is all done. It looks like wherever that's mated there. And I don't know if this is machined as one solid piece or welded on. I can't tell. I'm considering taking this apart, re-drilling it, and making a new shank and drilling that on there. I want to say this is a couple $100 for this one boring head here, and I've done some research online, and even buying a comparable import one, you're probably going to spend around $100. So I think it'd be fun to try to fix this one, and this one's American made, and a good tool. I'm sure it was just abused in its prior ownership. So anyway, hopefully we can get this guy straightened out, and I'm probably gonna have to just cut that shank off, machine the rear face down in the lathe, and then rebore and do like a press fit or something, and maybe then TIG weld that on there. I'm kind of debating on what I want to do. I don't know if I want to TIG weld it, because I think that I could possibly have some warpage there during the heating process and cooling. Even if I preheat it, I think that I might have some warpage issues, and I'm not the world's best TIG welder, so chances are I'm probably going to superheat the metal, and you know, that can create its own issues. So anyway, I will make videos on this process, and we'll just see what happens in the end. But we've got a good almost 20 thousandths run out right here towards the tip of the tool. That's going to translate into significant amounts. So basically, you're not going to have a straight bore no matter what you do. You won't have a proper finish. It won't be symmetrical, and it's going to suck. So there's no point in using this. And I found out the hard way as soon as I tried to use it anyway. The part did not come out within tolerance. So that's that. I mentioned also that I'm using the Noga dial indicator holder, and this thing is just fantastic. 5-axis control. It all happens with just the quick twist of that knob there, and then when you want to snug everything back up, you just do that. It has 170 pounds of holding force, and this is the best tool in the shop, bar none. I think this thing is just a super time saver, and with my other holders, which I've got tons of them, tons, I mean like probably 6 or 7 different types, this is the best one I've ever used. So I bought 2 of them. Actually, I have the other one right here. This is the one on the left hand, is the largest model they make, and these can be had for about $150 to $170 a piece if you buy them brand new through a supplier. And if you shop around on eBay, you might be able to score one for around $100, $110, $120, somewhere in there. I opted towards buying new ones myself. I've had some experience buying used similar items, and when they show up, you're not as pleased as you would have been if you would have just spent the full $1. So Alright, I'm going to show you guys what I'm doing to get my exact depth of cut on here. What I've got is the Noga indicator holder, and this is pretty, you know, ghetto or redneck, but I just took a clamp and I put that right on the tailstock. I don't know what that's called, maybe a quill or something. And so I have the indicator just resting on the saddle here, and then if I move the dial or the crank, you can see it illustrating the movement with the dial indicator. So this was just a really quick way to do it, and doesn't require much holding force because the actual plunging resistance of the indicator isn't much. So this is going to work, and then it will allow me to get an accurate depth for that. So just wanted to show you that technique. Alright, so we've got the boring head on here again after I've done my welding and all that other stuff, and we're holding within 2 thousandths run out. It's probably about 1.5 thou. So that's pretty good considering I suck at TIG welding, and we've fixed this thing that I was going to replace until I saw how much a new one cost. And I like the small head of this thing, and it holds a 1/2-inch tool, so yeah. And I like this brand. Seems to be really nice. The tools fit in there perfect. You can hear when I pull them out. You can hear that pop. That's nice. It's nice. American-made stuff's always good. And well, if it's production American stuff, it's just almost always good. I can't just say everything we make is perfect, but most of our industrial stuff is very well made. Very happy to support that. So, although we don't make Noga holders, and this thing is awesome. It's made in Israel. So anyway, really happy with that thing. It makes all these indicating jobs super easy and simple. So anyway, I suppose this is the end of this video, but very pleased with how this turned out. I was very concerned about how hard this was. It turns out it wasn't hardened at all. It machined very easily, and was just a total breeze. The whole project was. When I was TIG welding it, I didn't get very good footage. Damn, there goes that. Okay, there's downfalls to these Nogas. You loosen up one of these knobs and everything goes. So anyway, yeah, I got a phone call in the middle of recording the video with my iPhone, so that video is no longer with us. And long story short, I was just going to do a press fit, and then I decided that I was going to TIG weld it. And the problem was, I did a press fit and put Loctite in that thing. So when I did that, there was a lot of contaminants that, as I was TIGging, it was letting them out, and that caused some porosity. But the total fusion, I think, is going to be plenty for this thing's job, but you can see all the porosity there. Not really pleased with that, but we have a press fit plus the TIG fusion, so it should really hold up. And if it doesn't go, what I decided what I was going to do is I was going to cut this back off again, face this down, and then I'm going to make a 3/4 inch shank on here, and I'll TIG weld that bastard on there, because then this thing will go straight up into my quick change tooling for the future automatic tool changer, and that'll be great. So, but anyway, this is a nice compact little head. The model is a Criterion. Damn, that's all I got. I don't know what the actual model is unless it's a 002, which I'm assuming this is a 2-inch head, and this shank diameter is 500 thousandths. So anyway, thanks for watching. For the guys subscribing, appreciate that. It makes it worthwhile to make these videos if someone's actually watching them. I'm not a real machinist. I'm not a real anything. I just make stuff in my shop.